Okay, before we get going, we've got a list of questions we just wanted to go through, but could you please introduce yourself and briefly introduce Blockpliance?
Absolutely, Carson. Thank you very much for making the time. My name is Guillermo Fernandez. I'm the founder of Blockpliance, and we use computers to fight financial crime and digital assets.
Awesome. Yeah, so we met at the IBM Digital Assets Infrastructure event in New York City last week, and we got to talking about the future of blockchain DLT technology and what are some of the real impacts that it might have on society, financial systems, individuals on a daily basis. So any thoughts on our conversation last week that wanted to spark off a kind of a further in-depth conversation?
So the whole conversation started around the fact that I'm a former banker who then went into full-fledged crypto and AI intersection. And one of the things that my experience has shown is that most people, especially in the financial realm, tend to look or think at blockchain and crypto as interchangeable topics, when we know that crypto is just an application of the blockchain technology. And the real power there is not just limited to value exchange on money. So that's one of the things that we wanted to expand on, right? There is a misconception, and even though we have had crypto for a while, we've actually had blockchain for longer. We are fairly scratching the surface of what the power of these distributed ledger technology is going to be for databases and what that means.
So, okay, so maybe just the first question that kind of kicked off our conversation was, okay, blockchain, crypto. Crypto isn't blockchain, blockchain isn't crypto. Maybe can you elaborate on that? Because I found that very interesting when you explained it to me last week.
Absolutely. So blockchain is just a type of database. We are used in the past when we started coding and programming and when our parents started getting into this. You used to have centralized databases. They also meant that you had a physical server somewhere. So you used to have these stories where small companies would have a computer that would have a do not turn off sign somewhere because that was the server. That meant that if you turn it off, you kill the whole system or the whole computer, the whole database. Blockchain, in a very similar fashion to that, blockchain is just a type of database, but the power that it has is that it doesn't live on a centralized system. So there's not one single computer that if you turn off, the whole system shuts down. The distributed ledger technology, one of which types can be a blockchain, actually lives exact replicas of that data in different machines around the world. And they have different methodologies in which they make sure that everybody has the correct version of the data, the most up-to-date version of the data. And there are permissions written and stated by code, which are not arbitrary, meaning that not a single person can just change. Normally, you need consensus, which means that a pool of predetermined people have to agree on how you can make changes. So when we talk about distributed ledger, what we're really saying in mundane terms, it's the equivalent of having sort of a Google Sheet spreadsheet that keeps record of things, but we all can access and we all can read from as long as we have permission to access that. And instead of Google being the one that maintains that copy, it's actually a system that's open sourced for most of the time, meaning that nobody can really hack that one company. There's not a 1-800 number that we can go to. So that's blockchain. Am I missing anything, Carson? Would you like to add something to that?
No, I think I like the Google spreadsheet example. I think that's actually really great. I think one of the things about it, and we were talking about it, is a lot of the misconceptions, not only from your common public or broad knowledge publicly, but also in terms of C-suite at major financial institutions. There might be some misconceptions there. And I think that understanding what some of those biggest misconceptions are is number one. And then number two, explaining very clearly what the actual reality of those are is really important, and I think it's a communications language translation problem.
I agree. So blockchain itself is just a technology layer. It's something new that the world created late in the 90s, early 2000s. So we go as far back as that to understand what a distributed ledger would be. The misconception that we're talking about is the fact that people tend to think of blockchain immediately into cryptocurrencies, but you can use these type of databases for just regular data and other pieces of data. You don't need to use them for money in terms of cryptocurrencies. You can use files like FPFS and some other distributed networks that distribute files. You can encrypt images. You can transact other types of value that are not necessarily just money. So that's the first thing I want to say. Like, you could very well replace all of your data needs through a distributed ledger. You can have it be public around the world where everybody can access it, or you can have it be private, where maybe you're a financial institution and you have representations or subsidiaries in different countries, and your distributed ledger is only accessed by your financial institution with permission at these different countries. And one of the samples that we tend to see for that is permissioned blockchains, of which Hyperledger is one of the ones that's obviously started playing around with that idea of who gets to see which data, who has permissions, etc. So the same way, when you think of blockchain, and if people walk out of this conversation with just one thing in their, one thought in their head, I want it to be, when you think of blockchain, you should just replace it by it's a database. Now, when you think of crypto, we're going to have a different conversation there.
Okay, yeah. So, what would be that different conversation be? Because I have questions on the database bit and the kind of the differences, pros and cons to a centralized versus distributed database. But what would be the conversation you'd want to go down with crypto?
Cryptocurrencies is just one application of blockchain technology, but it became sort of the epitome of it because for the first time ever, we were able to prove that this technology solved a problem that had never been solved in this way before. So we had solved problems for distributed data in many different ways. I'll give you a silly example. I want to send you a very large file. I can't do it through email. So what we would normally do is go to a service like WeTransfer or any alike. We would upload it to their database, and then they will send you a link that you can access it. It's not a distributed network, but if you think about the solution, we solve the problem of accessing a very large file in a distributed way by putting it somewhere where we all could access it. Anybody with that link could just download it, right? We had never done something like that with money. So that's where the innovation of cryptocurrencies came about. The fact that if I send you that WeTransfer link and you download it, but unfortunately I happen to put it in the wrong place, or your email gets compromised or whatever, now anybody with that link can download that WeTransfer. And I'm just picking on that one because I happen to have used it this morning. But anybody can access that file. There's infinite copies of that file. That works okay if we're talking about pictures or videos or just regular documents. But it really doesn't work if we're talking about transactional value. Like if I put $100 bill equivalent and only you can access it, I need to destroy it after you access it. I will need to make sure that I don't have any longer a copy of that bill because I need to be able to spend that money. That is considered or called the double spend problem, which is the fact that you can replicate infinite exact copies of digital files. So we needed a way to make sure that when we send money to each other, the new version of that money got rid of the prior holder of that money, but also couldn't be replicated. And that's exactly what cryptocurrencies were able to solve.
Got it. Yeah, that makes a lot of sense. And it's the ledger component of it that's interesting too, because you're able to ensure that you don't have a copy of that. And whereas before, and I think this was the biggest use case with NFTs is, you might have, there's a whole subculture of memes and GIFs and there's real value to it just in any other standard art form that might be in physical format, such as paintings or graffiti or you name it. But there was just no ability to be able to say, this is the original or this is the real copy. And this allows you to do that. So you mentioned a little bit about the payments or the transaction component of this. And I think you had mentioned in a prior conversation we had embassy wires and how that is a really interesting use case for blockchain or DLT that folks maybe not be as aware of in terms of a real value proposition and what the real world applications of this technology could be like. Because I think getting away from, I just want to create a meme coin or, hope that Bitcoin's value goes immensely high. That's one component of it for sure. But the real applications are going to be what drives this into society. So can you just elaborate on what you were talking about with embassy wires?
Yeah, so the embassy wires case, it's actually particular because it uses a terminal wire, which we worldwide tend to associate with moving money from one financial institution to another one. But what we're really doing there, it's actually exchanging value. And embassies have been doing this for many years. So prior to the invention of the internet, we used to exchange telegrams and if you go on to study history during worldwide war, the way that we were exchanging these secrets was by actually sending either cards or communications that were ciphered. That is a type of cryptography. It's just not applied through technology in terms of computers. It was a different technology. We have to create special machines. We have to create a special codex. But that has now moved on, onto the technology world. And we started sending these cryptographically signed messages via internal communication systems. And at some point, those were leaked, right? Creating the whole WikiLeaks revelation, in which a lot of these embassy wires were accessed by the general public thanks to that leak. The new generation of that type of secret, it's actually using distributed ledger technology and cryptographic technology combined. So in many ways, it's a duplication of what cryptocurrencies do, but they're not exchanging any value. So embassies are not sending each other Bitcoin. What they're sending each other, it's a file that contains information that is only cryptographically accessible by the intended person to receive it. And they're doing it over permissioned networks, which means that you actually know who has permission to read it, who has permission to send it. And if somebody else happens to come across a copy of that distributed network, they might be able to see that somebody originated a message and somebody received the message, but they will not know who originated it, who received it, or what the message contains. Depending on the permissions, which at that level, when you're talking about state secrets, there are reasons why you actually want to have the least amount of data visible in the transaction. So we are able to protect that secret from moving from one side to another. In one of the conversations that we were having prior, it was all about how the world has been seeking or trying to emulate a way to protect secrets. And if you think about it in plain terms, the best secret we can come up with is the one that we tell to each other in person at a park with no recordings, right? Because then we are sure that at that point in time, only two people know about that one secret. Nobody else in the world has access to it unless one of those parties breaks that compromise. We've been trying to emulate that with technology. So we created cryptography to do that. We created ways to transport that information, which used to be databases, now are distributed ledger technologies. We created permissions on it. But I don't think that we still have figured out exactly how to do something as simple as just tell each other a secret.
Right. Yeah. As you were saying that, I kind of wrote down it's because that to me is a really valuable piece of technology or ability, is to take the internet, what you can do with the internet at scale. I can reach and communicate with anyone on the planet. And what you're saying is you can truly create a secret. And I wrote down, I was like, blockchain shouldn't be viewed as just a representation of value. It should be viewed as a value generation technology. You can generate new types of value with it. So I guess one hesitancy that folks might have, I've heard pros and cons to a central bank digital currency. You also have pros and cons to perhaps a digital identity. So I wanted to get your thoughts on what you think about the digital identity and perhaps some things that folks should be aware of when they're thinking about how convenient it might be to have a driver's license stored in the wallet of my phone.
So whenever you're thinking about putting proprietary information that also contains personally identifiable information on a distributed system that lives on the hot internet, meaning that anybody can access it, you have to think about the repercussions of that. In the past month, we just had in the United States a massive leak of Social Security data. As a matter of fact, I verified myself the file that we got a copy from through the dark web, and my own Social Security number with all of its associations, meaning the places I've lived in, phone numbers I've used, full name, names that match my name and different applications, it's there. So now I have a problem, which is that I need to make sure that my identity doesn't get misused for things that I don't intend on. Because somebody could call any financial institution and has all of the data to pose as me. And it's not only a Guillermo problem at that point, because this is a leak that to date, it's the most significant leak that we have seen of Social Security numbers. So problems like that can happen when data is connected to the internet, and there will always be someone somewhere with enough motivation and enough free time to want to access it. Sometimes for good intentions, sometimes for bad intentions, but we should not be counting on the statistics and the luck of somebody having good intentions with it, especially when there's value behind. So if there is financial value to be gained from, some bad people are going to want to access this data. Why am I giving this long prefix? Because at the end of the day, it's all about what the data can be worth to somebody else. If we're putting all of your identity on chain, which I don't think it's a great idea, it means that now you're going to have very strong ways to keep that information. And also you should make it selective. The person that owns that identity should have a selective trigger to what parts of the identity they want to reveal at different stages. Because what happens if, for example, you come from a country that values different things to the US. So you come from a country where maybe, freedom of speech is not equally valuable as it is in the United States. And for that reason, you get labeled to be a terrorist of ideas or a terrorist of information, as they're labeling back home right now for us in Venezuela. If you disagree with the election results, you're automatically labeled an enemy of the state and a terrorist of information. That's how they're calling it. So if that identity goes on chain, and now you have that negative flag associated with your identity that the state generated on you, what happens when I try to do, open an account somewhere, and all of a sudden a terrorist flag comes in? There is no way for them to differentiate that flag, or there's a potential where they're not going to have that way to differentiate that flag from somebody doing other bad stuff somewhere else. So I always think about a phrase that I was told by my co-founder, who served in the Navy for many years. And he says, when you're making deterministic transactions about good and bad, you have to understand that sometimes somebody's terrorist is another person's freedom fighter. And we don't have to get into arms and weapons and bombs. Like, just think about information, data. What happens if you say something that happens to be true, but it's not publicly beneficial? So think about Julian Assange, for example. So if you're moving your identity on chain, and these things can be written onto your identity, and you don't have a way to control who writes onto it or what do you disclose at what point, that could actually end up putting you in an awkward position where you stop being offered services. And these are primary need services. I'm telling you about like having a bank account or, entering a building or something like that, just because somebody was able to write on it. So I'm always very careful about, should we have all of identity on chain? I think that it's still too early on the technology. We haven't figured out really how to do the secrets portion well. Might we get there eventually? Probably, but we have to figure out some other things before. And I think that the perfect way to do this is actually the way that it's happening, by starting with money first, because money is the big motivator. So because we're now moving money on chain, there's a ton of resources being thrown at it to make sure that we do it efficiently. Once we figure that out well, then let's explore with other things. And eventually, once we have perfectized the process, if I may, we should then explore how to do identity. But it's too soon for us to be doing identity today.
Yeah, that makes sense. And I think talking about the data and information on chain, right, for example, or digital, you could think about it. The example you gave, I can't imagine the Social Security database was on a DLT. I think it was probably more likely a centralized database. But I think I'm differentiating those concerns between the difference of what a societal risk regarding data and information on chain or online is, compared to what are the technological risks to having that data and information on chain. And so those two, I think, are very different, because one of which you said was more of a, okay, well, dependent on what information is there, people might judge or act differently depending on what groups or circles you're a part of. And that's one obviously thing to consider. And then the other would be on the technological side of, do we have actually the security protocols in place? Do we have the ability to truly transfer and store secrets on chain in a secure fashion? I think you mentioned the difference between a hot and cold wallet, or storage rather. So I guess maybe question on the adoption of this type of technology, because we had talked about previously the $454 trillion worth of wealth. So money, value, that's a good first use case or area to attack this technology with. But we also kind of dove into a couple specific use cases. Is there a general or a primary barrier to entry or problem that you believe that we're facing in terms of wide-scale adoption of this type of technology or this type of online information data sharing?
Couple of points there. Number one, I think that blockchain in general, including its applications like crypto, have a branding problem. We've had this technology for long enough where most people should be already aware of it. But because of some of the ways it has been adopted, a lot of people just push that idea out. So branding, for branding and education, I think it's the number one problem that we have. The technology is complex, but to be very fair with you, it's not much more complex than the technologies that we're using or were using prior to this. And by saying that, I can say anybody that has a certain level of, existing or pre-existing technological knowledge can get into crypto very easily, can get into distributed ledgers very easily. As a matter of fact, because of large institutions adopting this technology, it's now easier than it has ever been. So you have very big, you have IBM, you have Google, you have Amazon doing their own versions in the cloud that allow you to manage distributed ledgers and blockchains. So if you don't want to deal with the infrastructure development of having to do one of these things, you can use something in the cloud out of the box that's going to work. When it comes to protecting secrets and all these things that we have been talking about, encryption, we have technology today that has been proven to work. But the problem is that we also have sort of a gray cloud approaching us, which is the doubt of quantum encryption, and whether or not that technology that we've had and been used since the 60s or late 60s, it's actually going to be enough to prevent a quantum break. So we're starting to see some papers, and we've been seeing this for about 8 years now. Watson researchers are among the ones that published a lot of this data of quantum encryption. The doubt, it's still too new. So in a way, we're at a point of intersection where the old technology works. It's good enough, but it's not perfect. But we have very early indices of new technology that could potentially replace the old one, but it's not proven. So I think that that's a bit of what's holding, like that combined with the branding issues, what's holding some of these financial institutions or worldwide institutions from starting to explore. Mind you, I see now in the last year and a half an exponential number of C-suite and high-level employees at worldwide institutions talking about experimenting, talking about doing something, working on a sample with distributed ledgers. When I started in crypto in 2012, nobody was talking about this at an institution. When I went into the bank I worked for and started talking about crypto, they thought that I was crazy. And for a very long time, they only saw crypto or blockchain as something related to money laundering. I think that has washed off already, and people understand that there is real value here. So it's a matter of how fast can thought leaders rise within the institutions to really replace the people who are not going to do it at this point out of ego or out of spite. So you need this new generation of thought leaders that understand that there is value here. And as you very well said at the beginning of the conversation, blockchain can not only move value, but can generate value as a technology layer.
Right. And I think that it's that second thing. I can't remember the gentleman I had heard, but it was on the Bankless podcast. He started off by saying, what is going to get this going? What is going to get the widespread adoption of DLT is not the fact that you can watch your Bitcoin or ETH value shoot up 10% or down 30% in a single day. That's not what's going to do it. It might be fun, and it might be great to try to make a large sum of value, but it's kind of more or less gambling in a way. But the real value, what's going to cause the widespread adoption, is that second part, is what is the value generation that this technology can create? What is the type of disruption it can cause to existing TradFi markets? And again, we said it's not going to do everything, but some parts of it. But then the second part is, what are the new types of things that it can create that wasn't able to be in existence before because of the way the technology was designed? Which gets me to my last point, and it's kind of more so maybe a two-directional question. One would be kind of more what is actually getting you excited about the possibilities of this technology. But then the second part is we talked about right before we hit recording is the kind of the more sustainability, kind of green planet capabilities or pie in the sky potentially ideas that people are coming up with this type of technology. So I guess maybe simply, what's getting you excited about blockchain technology?
Well, I think that the part that gets me the most excited about is that we have sort of grown up from the experimental stage, the part where anybody could launch a meme coin and it would go to the moon, and like that narrative, even though it keeps happening and it will likely live for a period of years more, we have really grown out of that in the institution realm. So people understand that yes, there is a very small segment of the overall population that uses this, that it's looking for these experimental toy-like components. But there are real values here that we want to explore in spite of all of these other things. So the fact that I have seen a change in how institutions are thinking about this gets me really excited. I think it's a combination of real value being proven and the fact that people that were excited about these other things in the past have grown up inside institutions to a point where now you have decision power and decision matrix and you can start to experiment. But it also gets me a little bit into the cost savings and energy savings component, which is financial institutions in general tend to run under a longer cycle for replacing technology. So you're not seeing your bank replacing core or centered technology every 2 or 3 years. It's more like a 6 to 8 year period. So we still have some financial institutions working with centralized databases, sometimes even centralized physical infrastructure, so servers. And then you have to replicate that data in many different places because God forbid something happens, a natural disaster or something, and that server farm gets, compromised. So you have to replicate that. There's a lot of waste in setting up servers, cooling them. There are, depending on which server you're using for what, they might be very expensive to get. So as people start to experiment with distributed ledger technology, some of these cost savings are going to start to be leveraged, where now you don't have to spend on these things. You can put it on distributed nodes that are easier to run, but have the same level of, natural disaster resistance. They are tamper-proof. You don't have to spend on cooling those machines, on maintaining those machines, on having security, physical security, like people walking around and making sure there's, server room, nobody's there kind of stuff. So what happens to compound all these savings because you're using a new layer of technology? And I think that at some point in the very near future, because we're approaching that 6 to 8 cycle from the last time that people were having this conversation, at some point we're going to start seeing a faster push, and it's going to be driven by internal incentives to save money on all these costs and to adopt technology that can actually propel us for the next 6 to 8 year cycle.
Yeah. That makes sense. And that gets back to that this is a value generating technology versus a value representing technology.
Yeah, absolutely.
Yeah. Cool. I mean, that's great. I think there was a lot that we covered that I think is really interesting. I think there's a follow-up piece that I want to do. You mentioned the quantum encryption and where we're at with that. Are you familiar with kind of the algorithms that NIST kind of approved? I think it was last week or the week before. There's a handful of ones that IBM had created that were approved and on that list. I think that's an interesting deeper dive. The branding issue, the branding problem is also really interesting. And again, I think it probably has to do with the first question we started off our conversation last week, which was the misconception of people think blockchain is crypto and crypto is blockchain, which is kind of true, but it's also a very narrow-minded way to think about the possibilities of what this technology can do. So, was there anything that we talked about that you felt that we needed to dive deeper on, Guillermo?
I think that a good conversation eventually is going to be talking a bit more about the CBDCs and its implications, because we have seen that in politically weaponized in many different countries, right? And it is one of the things that people also tend to have some misconceptions about. People say that a CBDC would give absolute control of the currency to a government, but in that narrative, which is true, by the way, in that narrative, people tend to fail at recognizing that through the financial system, the government already has absolute control over the currency. And we have seen that happen in many countries around the world where the government just decides one day that, you're going to stop using dollars, for example, locally, and everything needs to be replaced to a now devalued currency. And that in Argentina was called El Corralito. In Venezuela was called Viernes Negro, Black Friday, which has nothing to do with the Black Friday we know in the United States. But it's basically these scenarios where the government has imposed economic and financial decision on the banking layer, and banks have to comply. So how different is a CDBC from the current system? It's a conversation that we should have at some point, and ideally somebody, with an expert on that field as well. Because I will admit that I understand my side of the coins, but I don't understand as well the political implications that this might have, because I've never been involved in politics.
Right. I might have someone we could talk to, but anyway, with that, Guillermo, I think we'll wrap the first one. It's been great chatting with you the last 30 minutes and last week in person, and I look forward to more conversations in the future.
Thank you very much, Carson. I appreciate the time and look forward to it as well.